too late, you're already absent, Pierce. Horns and antlers. There are true horns, and then there are horns that we refer to as antlers that are not true horns. And the difference in true horns and antlers is true horns are never shed and they're found on both sexes. So what animal would you consider to have true horns? Cattle? Family Bovidae? That's it. Those are the ones you'll find true horns. They grow continuously, they're never shed, they're found on both male and female. So those are true horns. But remember, Bovidae, sheep, cattle are your examples in that category. Antlers are of the family Cervidae. We find those in deer, moose, elk, yeah. Only found in the males. The males grow the antlers and shed annually. And antlers are literally bone. They grow a bone structure nourished by an outer velvet capillary structure that begins to shrink toward the end of the summer. And as it shrinks and draws up and the blood supply seals off from that, then they rub their horns on bushes and it takes that off. And so now their horns are antlers, and sometime January, February in that range, they're going to start shedding those and go through most of the spring. I say most of spring. They'll go a couple months without anything, and then they'll start growing them back again with the velvet capillary structure for support and nourishment. Since horns of pronghorn antelope are similar to true horns of bovids, except that the keratinized portion is forked and shed annually. So they literally have a horn on their head year round. And from that point up, it's shed annually. The black forked portion of the pronghorn antelope is shed annually. So giraffe horns similar to antlers, but retain the nourishing capillary velvet. They never get rid of it. It's covering it 24/7, never shed. Rhinoceros horn, hair-like keratinized filaments that arise from dermal papillae cemented together, but not attached to the skull. So a little bit of difference in some of those, but we know the difference in true horns and antlers. And there is one exception to the antlers. In caribou, the female may actually have a set of antlers in caribou. So there's one example, one exception. Glands. Looking at glands here, we have sweat glands, and there's two categories of sweat glands. There is an eccrine gland, which is our normal sweat gland that's going to produce sweat that allows us for evaporating cooling during exercise. And then there is an apocrine gland. An apocrine gland is a coiled gland that's deep in the dermis, or in the hypodermis, that produces a milky secretion. Now, we have them, but we tend to take that one bath or shower a week and wash that stuff off so we don't notice. You noticed that, didn't you? Noticed everybody else didn't. They probably agreed to that one shower a week. That's the problem. What animal would you actually visualize this on quite often? You should know this one, Darren. Pam should really know this. I don't want to put any more pressure on Pam.
I'm going to say skunk.
No. This is not a stinking gland. Not a cow.
I was wrong.
But we're close. It's a farm animal. No, I said it wasn't stinking.
Horse.
It is horse. When they lather up, when you ride them hard and they lather up, that's the apocrine gland that's doing that. And that's on the study guide anyway. So if y'all had that study guide glancing down through there, we'd be nailing about half of these as we go. And your work will be done for you now. Blah, blah, blah. And then we make it to scent glands. Believe it or not, we have scent glands. Would you believe that? Is our nose sensitive enough to detect scent glands from other humans? Do we consciously know that though? It detects it. We just don't know enough to pay attention to it. So yeah, other animals, they're real sensitive to those. We mark territories with them. We mark boundaries. We establish reproduction probabilities with that, like deer creates a scrape, he leaves scent. The doe or the female comes through, she leaves her scent, he uses that to track, and that's a communication mechanism as well. So scent glands are multi-purpose. They say they're used for territorial boundaries, for warning, for defense. I mean, all y'all's had a wheel on your vehicle that's been targeted as part of something's territory before, right? Some dog. If a cat's rubbed on your leg, you were just territorialized with a cat rubbing on your leg. So they have their own ways of doing this. But these scent glands are in a variety of places: interdigital regions of metatarsals, orbital, of course in the skunk, we know where that one's at. Pica and woodchuck, it's found in their cheek. So it's just different places. And in fact, in humans, they did a study, they called it the dormitory effect. We study this in physiology. And the dormitory effect in humans, they studied college female women that lived together in a dorm and spent a lot of time together. Guess what they found, what happened over time? Synchronized their reproductive cycles. It sure did. And did they mean to do that? No. Did they know it was happening? Probably not. But we were sensitive enough, the scent glands in our olfactory senses was capable of utilizing that to synchronize. And it can happen between mom and daughter, sisters, and I've even heard cases of entire female basketball teams that spend a lot of time together. Some of y'all may be able to associate to that, but it does happen in all species somehow, some way. And the last thing they mentioned under scent glands is that humans are also endowed with scent glands. However, we tend to dislike our own scent, and that would be the BO scent that they're referring to. It's not, she's back there smelling herself. That's not good. Forgot that deodorant already this morning, huh? But that has stimulated a lucrative deodorant industry. If you don't have deodorant, surely there's some perfume laying around somewhere, borrow some from somebody. So we come up with anything to mask odors, right? All these different concoctions. Look at all the different shampoos and body washes now they call them, which is just a weak shampoo for twice the price. I mean, if you didn't have shampoo, you could use a body wash for shampoo, couldn't you? Just use twice as much. Your hair smells good though, probably raspberry floral. Who knows what it'll be. Good enough to eat though, that's how good it smells. Mammary glands, the last gland here listed below sebaceous glands, which sebaceous gland is just the oil in your skin. It makes up the sebum in your ear or wax in your ear. Bacteria really like this, and if this is not controlled at some point, then they'll sure grow in it. It's also known commonly as polite fat. I don't know where that terminology comes from, but so that it can turn rancid if not cleaned up from time to time. So do we need to clean our ears out every now and then? Sure. Do we use a Q-tip to do that with? Most people do, but you shouldn't. And you really shouldn't sit in class with your pen and pick in your ear either. That's not healthy as well, but it does happen. And of course, mammals get their name from mammary gland, and that's the last one listed here. Talk about its capability of producing milk. It goes on and talks about the difference in monotremes and marsupials and mammals and different types of milk production that they have. And that the monotremes, they don't even have nipples, as we talked about before. They just produce milk into a slight depression on their belly, and the young lap it up with their tongue. So mentioning lots of differences there in those in itself. Now in food and feeding, we have a tooth for nearly everything. Now some of the mammals don't. The monotremes and anteaters and certain whales may not have teeth at all. But most teeth have, or most mammals have specialized teeth for the food that they eat. If it's carnivores, they're going to have teeth for cutting, slicing, tearing. We have one for everything. We have what's called incisors for snipping and biting, canines for piercing, premolars and molars for slicing, crushing, and grinding and shearing. Now, there's literally a tooth for everything that we need to eat. Since we're an omnivore, we like a little salad with our steak, right? So we have a tooth that'll take care of all that for us. Now, on your study guide, it asks basically what kind of teeth do we have. And there's a term, it's not even in this book, it was in an older book, and I still use the term on the test, and the term is diphodont. Diphodont teeth. I hope I can spell this. No, I can't spell this. D-Y-D-I. Let me look it up over here. Diphodont teeth, literally mentioned, is almost the same as deciduous teeth they mention in here, in which they have two sets. We have our baby set, and then we grow our adult set. That's number 28 on your study guide, what type of teeth the mammals have, and that's D-I-P-H-Y-O-D-O-N-T, diphodont. Di means two, so that's where the terminology comes from. Now, there are some mammals that may have homodont teeth, which means one set. There's not very many. And then they use another term in here that's heterodont, which is a variety of teeth. Hetero means different kinds of teeth, and we also have that as well. Yes, ma'am.
Can you respell it?
Respell that. That means I've got to look it up again. D, I know it starts with a D. I-P-H-Y-O-D-O-N-T. All right, feeding specializations. Insectivores eat insects, herbivores eat plants. Those are specialized browsers, grazers, gnawers like rabbits and deer, kind of fit into that. And then you can get into ruminant animals that fit under herbivores as well. And on page 626, ruminant animals have 4 chambered stomachs. And the average cow fits this, 4 chambered stomach. And here's what the names of those 4 chambers are. We have the rumen, the reticulum, omasum, and obomasum. Those are the 4 chambers of the stomach. Probably ask you that on test. I'm not sure what number it is on study guide, but it's on there. So the rumen, this is where they graze the grass, swallow it down into the rumen, and it sets in the rumen with some bacteria and probably some protozoans, and it sits there and mixes a little bit, and then when they get full, they regurgitate some of that up and chew on it. They use their molars to grind down cellulose walls. Then they swallow it back down, gets more protozoan and bacterial activity, goes to the next chamber, which is reticulum. They get even more of the same. The omasum, more of the same. And the last chamber, which is the true acid stomach like we would have, the obomasum finishes off what is left. So they're pretty efficient, but it takes a while to get that way. And when we feed a cow, we're feeding the bugs in the rumen. And we call them bugs because there's such a variety from bacteria to protozoans that's in there. If you keep that flora of bugs in the rumen of an animal healthy, that animal's going to be healthy. Now, using a lot of antibiotics, will antibiotics kill bad stuff? Will antibiotics kill good stuff? You ever take an antibiotic that upset your stomach? Absolutely. It's killing your good stuff as well as your bad stuff. That's why it upsets your stomach, because it messed up the entire flora of your digestive system. So the same thing with these animals. So we use different enzymes, we use different cultures, yeast cultures, a variety of things to maintain a normal flora in the rumen of these animals and makes them more efficient at what they do. That's what does the digesting for them. Moving from there, it gets into a little bit of size of animal and efficiency, and still talking about carnivores as well, but at the bottom it says an African elephant weighing 6 tons, that's a large animal, isn't it? Must consume basically 300 to 400 pounds of food a day to maintain normal nourishment for life. Now they use the reference of rough fodder, which would be some type of hay-like substance. But still, 300 to 400 pounds a day. So how long would it, 3 days, an elephant's done with a 1,000-pound round bale of hay. 3 days. Be tough to feed him, wouldn't it? But when you take the small mouse that must consume its body weight every day or more, and if it goes a few hours without consuming a food source, it may actually die. Which one's more efficient? The elephant that weighs 12,000 pounds, or the mouse that weighs only a few grams? I thought that was a no-brainer question, and I got no answer at all. Which one's more efficient? The elephant is more efficient. Thank you very much. You buffaloes over there aren't helping me at all. Y'all should have known that. Buffalo's the closest thing in here to an elephant. Well, carnivores are mentioned on the next page. We know carnivores eat meat. Would you consider yourself a carnivore? I'm kind of a carnivore. But technically we're omnivores, but omnivores eat both plants and animals. So it says in here that in general carnivores lead more active lives while we're out there hunting, right? So a coyote or a big cat at some time, they're running solitary lives instead of in groups. They're hunting down that prey that, a cougar may kill a deer a week to eat on. If there's more prey available, they may kill more than that. But a cow's constantly grazing grass, you never know where the cougar is next. There's like no boundaries. Where's it going? What's it going to kill next? We know what the cow's doing, don't we? She's either down there eating, drinking, or chewing her cud underneath a shade tree somewhere. What boring life compared to excitement. What's next on the plate of the cougar, But we've changed the rule on this. We as humans don't particularly like competition to food sources we like. Now granted, if the cougar is deciding to take down a baby calf or two, and that's what you're raising for a living, that's not a good situation. So what do we do to the cougar?
Kill it.
We hunt him down, just like he hunted down our calf.
You gave permission first?
For a cougar? Not in state of Oklahoma.
Really?
Fair game. State of Oklahoma, now you're supposed to report it after you kill it, but you kill it only upon a cougar being a threat to something that you own or yourself, which everything would be a threat in most people's opinions. They crossed the road, they threatened my vehicle. Well, why'd you shoot it out the window? How else was I supposed to shoot it? I couldn't chase him down. Well, why'd you shoot it between the eyes? Well, it's where the light was shining. That'd be southeast Oklahoma, taking care of cougars right there. I can't believe I put that on film. I want to get myself in trouble one of these days. This is just what I've heard from other people say. Never do that. But we have changed the rules. If we're out turkey hunting, we're calling this old gobbler boy. We've about got him talked into coming up here and seeing us. Here's something behind us, coyote sneaking around. What do? We shoot that coyote, don't we? We'll come back another day for old Tom, but the dadgum coyote's trying to get in their way. How dare him go down there and jump on that Tom? Or the hen that's with the Tom, whatever. So we take the coyote out of the picture. That's how we change the rules. And a lot of it's based off what happened up in Yellowstone years ago, and it's still a problem today. Yellowstone allows no hunting, no permitted hunting, no regulated hunting, nothing. And the wolves regulate populations. That's their natural predation situation in Yellowstone. But they run into a lot of disease and starvation only to find that there was very few wolves in Yellowstone. Where'd they find them? Down out of Yellowstone at the farmer's pen down there eating the sheep that's in the pen. So what happened to the wolf at that point when the farmer caught him eating the sheep? Snuffed him out. So they had this big meeting about, if the wolves are coming down out of there eating our sheep, let's allow controlled hunts, permit hunts to get populations of elk and the deer and bison, whatever else up there under control. Oh my gosh, I thought the world was gonna end right there because somebody said shoot something. And needless to say, it ended up, they went and got more wolves from Canada and brought them in there. Now they're almost in Oklahoma now, they've scattered so much. They've come down through the Rockies. There has been some sightings in Oklahoma, all the way down into Wisconsin and Minnesota. The Great Lakes areas has plenty of wolves now that they didn't used to have, all brought in here to control Yellowstone, which they're not there. There's some there, but we still have disease and starvation. When natural predation, which with us being an animal ourselves, considered part of that hunting regime out there, when natural predation does not take care of population increases, then disease and starvation does. Do you not see it in the human population across the world today? We see disease and starvation all over. It'll happen in any animal species. Then last just mentioned is omnivores, pigs, raccoons, bear, most primates, including humans, use both plants and animals. Body weight and food consumption, I think we covered that with the elephant a while ago, but it does mention a 3-gram mouse will consume per gram body weight 5 times more food than does a 10-kilogram dog, and 30 times more food than a 5,000 kilogram elephant. Now this is a little smaller elephant, while ago it was a 6,000 kilogram elephant, I think. So they're changing their sizes here. The smallest shrew, they don't get much smaller than this, weighing 2 grams, may eat more than their body weight each day and starve to death in a few hours if deprived of food. In a few hours. That was like that pressure every day. In contrast, large carnivores can remain fat, healthy from one meal every few days. Mountain lions kill an average of 1 deer a week, although they kill more frequently when game is more abundant, which makes sense. Migration. Now there's more study guide stuff here in this section. Would you agree though, migration for mammals is more difficult than migration for birds? It's a much easier thing to get on a plane and fly from here to Dallas than to walk from here to Dallas, wouldn't it? They'd get there faster, more efficiently, more timely. But saying that, there are a variety of mammals that do migrate. The first ones they mention are the bearing ground caribou that migrate twice annually. They have breeding grounds and feeding grounds, and they migrate back and forth to those, anywhere from 100 to 200 or 300, 500 kilometers that they may travel. And usually when they start on their migration, they stop very little to eat. It's go here, do their thing, go here, do their thing, and in between there's not a lot going on but travel. And males must be leading that because they don't ever stop. They don't stop for anything, they just keep going. Don't even stop for directions. So they mentioned the bearing ground caribou 100 to 700 miles back and forth in their migratory trek. These caribou go from ranges in the boreal forest. They migrate rapidly in late winter and spring to calving ranges on the barren grounds, the tundra. The calves are born in mid-June. As summer progresses, caribou are increasingly harassed by warble flies, nostril flies that bore into their flesh. I just like to be harassed by flies that just drill holes in you all the time. Now that's not the worst of it. How about these big mammoth mosquitoes? They're sucking blood out of these caribou equal to about a pint of blood a week. Yeah, they're not going to stay here very long, are they? Too much harassment. So the calves are born, they get out of there. Lots of food here, so they get fat while they're there. It's like all these pests know they're coming, so they're just waiting on them. They get their one meal of the year, and that's it. But you know, this is the small time frame in which the tundra is actually functional. The rest of the time it's frozen solid. So lots of water, lots of mosquitoes. We finally warm up enough to get the mosquitoes and the flies and all that, and that's when they graze, grow fat, and move on. And of course, what follows them there? The wolves prey on the calves. It's a good place to catch a little one. They move southward in July and August, feeding little along the way. In September, they reach the taiga and feed there almost continuously in low ground vegetation. The mating rut occurs in October, and usually in that same area they'll stay, and then they'll start migrating back when it's time again. So, then plains bison. They had a circular migration that they did on an annual basis. What migrated with the bison? Think about it. Who's the predator here with the bison? Man, the Indians. Did they not pick up their teepees and follow their food sources? Absolutely they did. So we were pretty good migrators at one time ourselves. Gray whales migrate between Alaska in summer and Baja, California. So they have winter homes and summer homes. Some of us are just lucky to have a home. It's so true. Here's a study guide question on there. What's one of the greatest migrators here? And not sure what question it is, but the northern fur seal is going to be the answer. They breed on the Pribilof Islands, approximately 300 kilometers off the coast of Alaska and north of the Aleutian Islands. From wintering grounds off Southern California, females journey as much as 2,800 kilometers or 1,740 miles across open ocean, arriving in the spring at the Pribilof, where they congregate in enormous numbers. Young are born within a few hours or days after females arrive. Then the males having already arrived, let me tell you why the males had already arrived. They never left. They hung around. When the females left and the young left to start with, the males never went far because they knew where the females were coming back when breeding season was happening again. So why are we going to chase them around all over the globe when they're just going to come back? So I don't know if it's lazy or smart. Lazy, of course, would be a female choice there for the male. Lazy. And it says, males do not follow, but remain in the Gulf of Alaska during the winter, just waiting for the female. They probably are prepping up the home, probably have it cleaned up real neat and nice, waiting for mom to come home. Not a good suggestion, probably. Bats might be expected to be pretty good migrators, but really they probably migrate the least. To have wings, they might live in Oklahoma in summer and go to Mexico, or at the most. That's about as far as they're going to go. Some of them don't go anywhere. They live the same place all the time. But they might go from northern United States to southern United States, but typically not out of the States. Of course, we know the bats have come into a niche that birds left empty. That's an insectivore nocturnal niche. That's what bats do. And when you think of bat, what really comes to mind? Well, it can't be the St. Louis Cardinals because they've left their bats home the last 3 nights. So, like that one, well, they made me so mad I almost just disowned them last night. What kind of bat do you think of when you think of bats? Vampire bats, yeah. Everybody has this fear walking around at night, and you're always glancing over your shoulder thinking, out of the sky, this bat's going to come diving in and run on your neck, and 2 fangs goes into the jugular, and you're out. You're gone. He sucked you dry. Oh, that's not going to happen. Number 1, we don't have any vampire bats around here. Number 2, that's not the way they work. They're real sneaky about what they do. They don't just come out and attack you. They have to be pretty sneaky is what they do. Vampire bats do exist, and they do drink blood. That's their primary food source, but they don't have 2 monster fangs that jug in and slap into something. You don't see them hanging on a horse's neck right into their jugular and taking a horse down. What you might see them doing, though, is hanging off the edge of a leg, and they take their razor-sharp teeth and make a slight slice in the skin, just enough to get blood flow. And then they'll take their little tongue just like a dog and lap it up like a dog. But their saliva has anticoagulants in it and keeps the blood flowing instead of clotting. And they get a blood meal that way. Now, you think that's easy to land on the leg of a mule or a horse or some type of animal and take teeth and shave into the skin without getting beat up a little bit? I think they're going to get reacted to, but they maintain consistency until they get it. Now, they have to have a blood meal every 2 or 3 days or they'll die. And they live in huge colonies. So let's say this one bat goes out 3 nights in a row and gets nothing. Well, his old buddy, he's been so lucky the last 3 nights, he's eaten so much he just gorged himself. And he notices his buddy's getting thin is hanging right next to him. He's awful poor and weak. He hadn't had a blood meal, so the buddy that's had plenty regurgitates some up and gives it to him, shares the blood meal. And they do that to keep the colony alive. If they don't do that, everybody in the colony will note that. And if you have 3 bad nights in a row, sorry, you're not getting shared with. So it's share and share alike, or don't share and die. That's a kind of a way to get their attention, and
They don't ever eat each other.
it's a house rule.
They don't ever eat each other.
Eat each other? Oh, no. They don't glance over at their buddy hanging there all fat and sassy and say, I think I'll take his jugular out. No. They're trying to get along here. It's all family. Of course, we could argue that one probably too. So flight and echolocation is basically how they know where they're going at night. Can bats see? They have better sight than you think. A better sight than we're led to believe, because we always hear the term blind as a bat. But they actually have pretty good sight. It's just a problem of flying around at night. You know, night doesn't help sight any. So they have this unique technique called echolocation, where they send these beams of signals, and when they're getting close to something, they're honing in, it tells you there somewhere in here, it goes from 5 to 10 pulses per millisecond up to 200. Just bam. They're gonna make sure they've got it honed in here. We're not gonna miss it. Do all this work and pick up a leaf? No, we want the insect. So they're pretty accurate at what they do. Now, they may be an exception to this. If there is, I'm not familiar with it, but there's typically an exception in all of them. But all bats, regardless of what they eat, are nocturnal. Even the bats that eat fruit-eating bats. So, if you like bats and study bats, who knows? You could find your soulmate right there. I know a geneticist that was studying bats one time in Australia, and this was a fruit-eating bat, and he was the fruit of the trees that the bat ate. They weren't abundant, but there was enough. Well, when he was observing the bats feeding one night, he run into now his wife, who was a botanist studying the rare tree that this bat consumes. I think they got married right there. That was love at first sight. At night. Moving on to 632. Y'all aren't real excitable today. Y'all not helping me a whole lot. Reproductive cycles. Now, I've covered the 3 basic reproductive cycles. When I talked about we had marsupials that specialized in milk production. Remember the red kangaroo that produced offspring, almost became pregnant immediately. When that joy is big enough to get out of the pouch, then this one starts growing inside. Remember that process we went through? Okay. Then we had what? We had the eutherians, which is us, the placental mammals. We spent all of our time in gestation. The marsupials spent their time in specialized milk production. And then what's the other ones? The duck-billed platypus and spiny anteater. Okay, the monotremes. There's an egg laying. They lay eggs and they produce milk, but on a depression on their belly. So there's the different reproductive patterns that they're talking about on 632 and 633. At the beginning of 632, though, they talk about estrus cycle. On your study guide, estrus is in reference to the time at which the female will receive the male. We commonly would refer to that in the animal world as heat, a heat cycle. What number was that? We found it. What number? 42. And then animals that have only a single estrus during their breeding season are called monoestrus. Those having a reoccurrence of estrus during the breeding season is called polyestrus. Dogs, foxes, and bats belong to the first monoestrus group, where field mice and squirrels are all polyestrus. There are many mammals living in the more tropical regions of the world. And then a different cycle in which the post-ovulation period is terminated by menstruation, and that's where the term menstrual cycle came. That's where the humans fall into place here, with, I'm sure, some of our closest cousins, apes and monkeys. So the menstrual cycle falls in that category. Now, of all these cycles we're talking about here, there is one particular group of animals that we should be really familiar with that ovulate after the heat cycle. They don't ovulate during the cycle, in the middle of the cycle. You know what animal that might be? It's not deer. Deer. Take another guess. Name an animal. Since this is zoology, it's a good start.
Squirrel.
Squirrel. It's not a squirrel, but thank you for naming an animal.
Zebra.
Zebra. No, you're close. It is four-legged. It's not a horse because they would be the same as a zebra. What? It's not a pig. It's a cow. Yes, it is. Cows ovulate after they go out of the heat cycle. It's odd, but they do. And because of that, if artificial insemination is taking place, when you find them in heat, you wait 12 to 20 hours to actually artificially inseminate them because you want the egg and the sperm to be timed. What was that?
We missed that with Hannah's heifer.
Oh, yeah. Well, you should be consulting your local ABS representative. That would be me. That'd be me. I could have helped you on that one. All right, now, in the red kangaroos, I'll be brief with this because we kind of already covered it. If you recall, they'd give birth to young, crawl over in the pouch, and almost immediately get pregnant again. And then they'd reach a 100-cell stage and just sit there. And they'd sit there 200 and something days, it tells you in here. 235 days, it'll just sit there, as long as the other one's alive and well. And they call that embryonic diapause. Our native black bear do the same thing. Very similar to that. They'll get pregnant in summer, it'll grow to a certain stage and just sit there until late fall, and they'll start growing again and give birth in January. They go into an embryonic diapause. So, now look at some gestations over on 633. Gestations is the time in which an animal is pregnant before they give birth. 21 days in rabbits and hares, 30 to 36 days in cats, 60 days in dogs, and these can vary a little bit. Most dogs you'll look and they'll say 62 days. Well, what's 2 days, you know? Cattle, 280. You read another one, it'll say 283. You look at a specific breed of cattle, it may say 285, or it may say 279, or it may say 284. On specific breeds, their gestation's slightly different. Why? Who knows? And then the largest of all mammals, a baleen whale, 12 months is what they're pregnant. And then an elephant's only pregnant for a mere 22 months. That's an elephant when it gets here, isn't it? I don't know, it's big when you think. All right. Took care of that. Let's look at territory and home range briefly. Mammals are territorial. I told the other class, if you have a beware of dog sign and no dog, you're still territorial. Those are the worst signs. If you lock your house, it's territorial. If you have a posted sign up, you're territorial. So we're territorial. We already noted that birds are extremely territorial. Do you think deer are territorial this time of year? They're getting that way, aren't they? My son was out Saturday morning bow hunting, and from a distance he was able to watch a group of doe and one little forked horn, and that little forked horn's having a ball. He was chasing doe everywhere, of course, it's just having game kind of thing. And here come a little 6-point in, and forked horn thought, he's not that big, I'll take him. So they get in a big fight, and then they end up kind of splitting the herd, and they both doing some chasing around, and directly here come a little bigger deer. The other two they left. They had already been beat up before, and he wasn't the big daddy. He's the medium daddy, but they didn't want none of him either. So they left, and that battle had already been determined at some point somewhere else, and they knew they didn't want that whipping again. And that's part of another chapter of survival of the fittest. And the strongest will continue the species, and you may be the strongest this year, but not next year. You may be the little forked horn this year, but you may be the big daddy next year kind of deal. So it's, if you survive the bad years, you'll get a good year or two in there if you survive the bad years. So deer are really big on home ranges. They cover a huge territory. It's not uncommon for 5 or 6 mile radius to be covered in one day for some dominant bucks. And that'd be a home range. Now within that is an area they like to stay a lot, and that's a territory. These little bucks, can they pass through the home range? No problem. Can they pass through the territory? Don't stay very long. I mean, that's the attitude that they have. This is my territory, this is mine. And they've established that, and it's respected. So there's kind of territory and home range. These prairie dogs kind of have it figured out. They establish territory, raise young. When the young gets big enough, as with most young, they pretty much tore up mom and dad's house. Mom and dad don't tell them, they just move and build a new house and leave all the old house with the young they just had. It's a good idea, isn't it? I'm thinking about that one. All right, mammalian populations. Runs in cycles of abundance, just like their food source would. And they use an example of American lemming. The North American lemming is like a little gerbil. And they populate, you think rabbits populate fast. These things populate fast. They're a lot like mice. It's about 21 days, but they're weaned in 2 weeks. And about 2 to 4 weeks after that, they're capable of reproducing. The offspring's capable of reproducing again. So you can see how this can really multiply in a hurry. Well, they tend to eat grass, vegetation, roots of the vegetation. And you get enough of them, they can just totally devastate an area. So when that happens, starvation kicks in, and so they're gonna go find more food. So they just have a mass migration. And it's almost like they wake up one morning, glassy-eyed, and say, we're going this way. And every one of them head off in that direction. So if they come to a pond, they jump in, swim the pond, come out on the other side. They don't go around. It's a straight line. And they can't determine a creek from a pond, from a lake, to a river, to the ocean. They can't determine any of them. So if they come to the ocean, they jump in. Guess what happens? They drown. If they come to a cliff, they jump off. Isn't that a way to handle density populations there? We just lost a large population. What happened to them? They jumped off a cliff. It's mass, they say it's mass traveling or mass migration. It's mass suicide is what it is. And but when that happens, it actually takes a couple of years for that population to start building again. What happened to the forage and the plants and the things that they had devastated? They had a chance to come back, didn't they? Nature takes control somehow. So, well, we're going to blind the guys and tell them to go east. Well, where are they going to run into? Eventually, the ocean, and then they'll die. So that's how we take care of it. Snowshoe hares. We've always had this idea of how fast rabbits can reproduce, right? Well, snowshoe hares, they noticed in snowshoe hares that they'll reach such a cycle of abundance that they quit breeding. They absolutely start hating each other, and they commence to fighting amongst each other, and they go into what's called a pituitary adrenal gland exhaustion. And they actually literally call it shock disease. I mean, it's just everybody's mad, everybody's fighting, and a lot of them just kill over dead. It just kills them. The ones that actually survive it are left to continue the species again. And they get over it, and they decide that they love Susie over there, and they start reproducing again, and then they reach this high population level again, and they hate everybody again, and they go through the shock disease, and here we go again. So again, it's disease and starvation that takes care of population densities in which predation has not. Make sense? Something's got to take care of them, right? I'm hanging on to my rabbits. I may need to eat them this winter. Economy keeps getting bad. Any questions? Finish the chapter right there. See, I told you I could get through it. Now we need study guide, which we've covered a lot of the study guide already. If you've kept up, you should have most of this. Who's been working on the study guide? Oh, one person. Oh, you come in late, been working on the study guide. That a girl. So do you have any particular questions that got you stumped? Maybe? Maybe not. Now, you told me you've been working on study guide.
Me?
Yeah.
I have.
Okay.
Mine's almost done.
Well, ask me questions of those you had trouble with. Didn't have any trouble with them?
54.
We're ready for a test.
54.
54 says, what happens to an animal during the growth of antlers? Well, and not so much as what happens to them, is that what do they need? During growth of antlers, they need a lot of calcium salts to build bone, because that's what antlers are. So they have to increase their intake of calcium salts.
That would've been a hard one.
Otherwise, if they don't get sufficient intake of calcium salts, you see little bucks like we see in southeast Oklahoma, just little gnarly, goofy looking horns with mineral deficiencies. We see it in the soil. They're getting better though, because we tend to supplement that from time to time. Trowbridge, I know you don't put out any supplement for deer. But snares around it too, probably. What
type-
else?
What type of islands do snakes have?
Immovable. They don't move. What number's that? 33. Immovable eyelids is what snakes have. Remember, they have the covering they call the spectacle. That's what they have. What else? I know somebody's got a question about 9.
6. Snake.
Vipers have what?
Fangs.
Fangs and are ovoviviparous.
Okay.
That's a good guess though. Vipers are poisonous, aren't they? Ovoviviparous, that's their mode of reproduction. You can't spell ovoviviparous, Miss Buffalo? It's got a couple O's and a couple of V's in there, and they put iparous on the end.
On 7, is it positive pressure breathers? Is that
Yes, it
dangerous?
is. That's exactly right. Frogs are positive pressure breathers on 7. What's your most aggressive reptile?
Snake.
Crocs.
Crocodile.
Crocs.
Snake.
Somebody yesterday asked me number 3, what are the least specialized amphibians? No.
Oh, yeah, I did.
What'd you get?
I didn't.
You didn't? And? Salamanders and newts. What'd you get for 10? Snakes are mostly
Oh, viper.
oviparous. And they lay their eggs. They lay eggs, yeah. Mostly sleepy. I don't know, doesn't even fit in there.
You can put that as a selection.
I should. I know somebody will miss it. What's next? What determines sex in alligators? Number 14.
Ground temperature.
Nest temperature. What do birds use in migration? 16.
Which one are you on?
Their internal compass.
Use wings in migration, is that what we're?
What are you on?
I'm on 16.
Magnetic fields.
They use, that's one of the theories. Innate sense of direction, sun by day, stars by night, it's another theory.
Memories.
It's all a bunch of theory.
Memories from childhood.
Learned, yeah, instinctive.
They follow rivers. Doesn't know
Which of those is the answer?
Could be any of them. Take a guess.
So in other words, all of the
It's
above.
gonna be an
or
all of
this.
the above.
Or none of the above, or the other.
It's your guess as good as mine. I'm giving you lots of options though. What is second to fishes in number? Birds. What is altricial?
Naked number.
Naked. That's right, it's good enough, naked. We'll just leave it naked. How are feathers shed?
Highly ordered
Highly
process.
orderly manner.
Yep. Let's see if there's another one they asked me quite a bit about. What are the only true flying mammals? Bats. They mentioned flying squirrels in there.
Yep.
They're not true flying mammals, they glide. You threw them from top of a tree, they glide down, but do you think they can fly back up? No, they'll crawl back up.
With assistance, I can fly back there.
Yeah, if you take them and chunk them, plaster them on a limb somewhere.
What about 21?
21, what part in birds increases respiration for flight?
Lungs.
Air sacs, the 9 interconnecting air sacs.
45.
45? I get there. What are the truly first terrestrial vertebrates? What is dinosaurs considered? A kind of,
Reptile.
that's it. That one was so ancient, it was too easy.
Is
It-
the monotreme, like a platypus? Is
Yes.
that what it is?
Monotreme is duckbill platypus or spiny anteater.
Is 52 wings? Or feathers, I mean?
52 is a lightweight skeleton,
No.
highly efficient respiratory system, high pressure circulatory system, and well-developed nervous and sensory system. So they're just good. What else? Did you get 43?
Northern Versus.
It is the northern fur seal, very good. How about 46? Somebody asked me this one, although I covered it when it was in that chapter. What's the 4 orders of reptiles? Sphenodonta, Crocodilia, very good.
Is 48 yes or no? To yes is to fly or something, but they can be bald.
Must feathers be shed at regular intervals?
Yes.
Say
Yes.
It's called molting. Isn't it?
Yes, it is. And how are feathers shed? Which is another question on the beginning of this.
Matching, like they match
Number
each other.
20, how are feathers shed? In a highly orderly manner.
They match each other, like if they lose one, this end doesn't.
Very ordered. We lose 2 of these, we're gonna lose 2 of these, just like it.
That's 22.
22. What's an example of a bird with soaring wings? Albatross. High-lift wings.
Oh,
Hawk, eagle, vultures,
Raven.
owls, raven, no. No raven.
On number 12, are there quite a few ways that you only have to list 2? Or no?
2 ways reptiles are more advanced. There's a lot of ways.
Okay, they're listed in that chapter.
Yes, they are. 2 real, probably at the top of the list, is thicker skin for more protection. And they do lay a shelled egg. That advances them into a terrestrial environment where the frog lays an unshelled egg into water.
It protects the living.
Yeah, the water kind of swells up inside of it and has a little membrane covering. It's good to go. Hopefully it'll hatch in a week or 2 or less. Depends on water temperature. What else? Nothing?
Yes, yes.
What are
Give
2
me a
human
second.
activities that have an impact on sperm population?
Deforestation. What number is that, everybody?
49.
49. Human activities that have had an impact on certain bird populations. We're gonna have to quit, I can't even read. Deforestation and draining of marshes. Draining of marshes. Deforestation, remember they said that we remove the tropical rainforest in the amount equal to the state of Washington on an annual basis. That's how much deforestation is involved. They have no wintering home to go to. It's like if we was wealthy enough to have a home in Colorado and one here, if we come back here for the winter and somebody burned it down, that wouldn't be good, would it? We'd have no place to go.
If you had that much land, probably worry about it.
True, but poor birds didn't have any money. They just live in what nature had to give them. And we took it away.
Isn't that bad over time though? You can go somewhere else.
Sometimes they do, sometimes they know no other place to go. Of course, we probably cut their forest down, and deprive them of wintering homes to make us one.
About 41.
What are structures that are derivatives of mammalian integument? I didn't know if anybody ever asked that or not, but this is one of those if, ands, or buts questions. There's a lot of derivatives of the mammalian integument. There's hair, the variety of glands we listed today, nails, claws, hooves for even some form of integument. But what you're gonna be looking for is which one is not part of the integument, and it's something superficial. Part of the integument has to be superficial. So if you find a gland that's not superficial, name a gland that's not superficial. All right, let's just name a gland.
Thyroid gland?
Thyroid gland's not really superficial. I mean, it's down in, it's not part of the skin like sebaceous, sweat, sebum. It's not part of that. So what about a prostate gland? Is it part of the skin? It's not, is it? So you're looking, if you're familiar with what would be part of the skin, then you're looking for what doesn't fit in that question. So yeah, we're gonna have to think a little. Anything else? 37? How does the nervous system contribute to the success of birds as flying animals? What do you think? What are they good at? Birds not good at anything? I don't guess they are successful then.
Pretty good.
Seeing flying?
Coordination, balance, coordination.
They can breathe pretty good too.
Do what?
They can breathe.
Yeah.
Respiration.
Balance and coordination is gonna be your biggest one. I don't even remember what, yeah, 38, was that 37? Yeah. Balance, coordination. Y'all ready for test on Thursday? You know we're starting frog this week, right? We got a test, frog, next week frog test. And we start, is that when we start presentations with the frog test? Oh, we start it next week? Oh, we don't do presentations?
When's the 8th? It's like 2 weeks from now.
So we'll take the frog test and start presentations on the 8th. Does that sound right? Yeah, okay. That's where we're at then. I'll see y'all Thursday. Thank y'all.